Dear friends, I am now moving to Cracking Uncertainty with Probability MCQ Part 2 of Module 4. This is part of Test Your Knowledge in Business Statistics in the Age of AI. Let me start with the questions one by one. Question 4. Conditional probability in marketing. If the probability of a customer clicking an ad is 0.3 and the probability of purchasing after clicking is 0.5, what is the probability of a customer clicking and purchasing? Pretty simple. Think about it and select your answer. Let me now give the answer. The choice is A 0.15. That's the correct one. What you are required to find out is probability of click and purchase, which is equal to probability of click multiplied by probability of purchase given click. So this is equal to probability of click is equal to 0.3. Probability of purchase given click is 0.5. Multiplying the two, I get 0.15. So choice A is the correct answer. Question 5. Bayes theorem in fraud detection. A credit card company identifies that 5% of all transactions are fraudulent. If a fraud detection system has 90% accuracy in flagging fraudulent transactions and 10% of non-fraudulent transactions are incorrectly flagged, what is the probability that a flagged transaction is actually fraudulent? That is the question. All of you know Bayes theorem is very important. It is an extension of conditional probability. In situations, for example, you are given prior information on probability of A given B, but you are supposed to find out the probability of B given A, which is a matter of interest to you. And just a very interesting way we can look at this problem. Let me now come to the right choice in a step-by-step manner. Using Bayes theorem, the question says, what is the probability that a flagged transaction is actually fraudulent? So, what we want to find out is probability of fraud given flagged. So, I can invert it. This is equal to probability of flagged given fraud multiplied by probability of fraud divided by probability of flagged. You know very well, if I expand this left-hand side, probability of fraud given flagged equal to probability of fraud and flagged divided by probability of flagged. The denominator is probability of flagged using conditional probability. But probability of fraud and flagged, I can write it as probability of flagged given fraud into probability of fraud. And therefore, I need to first of all find out the denominator, probability of flagged. So let me do that. Probability of flagged equal to 0.9 into 0.05 plus 0.1 into 0.95, because 95% of the transactions are non-fraudulent, 5% are fraudulent. Multiply this by 0.9, that is the first expression. 95% of the non-fraudulent multiplied by 10%, which is given in the problem. So it will be equal to 0.045 plus 0.095. Adding the two, I get 0.15. So the denominator is obtained. Now, let's come to the numerator. Probability of fraud given flagged is equal to probability of flagged given fraud, which is 0.9, into probability of fraud, which is 0.05. Okay? That part, denominator 0.14 must be retained. This is the expression. When I simplify, it is 0.32. To recapitulate, let me repeat again. It's a very involved problem. We are supposed to find out probability of fraud given flagged. I can write this as probability of flagged given fraud into probability of fraud divided by probability of flagged. I calculate probability of flagged, which is equal to 0.9 into 0.05 plus 0.1 into 0.95. And simplifying, it becomes 0.14. So the denominator is known. Therefore, now I come back to probability of fraud given flag is equal to 0.9 into 0.5 divided by 0.14. Only this part will be in the numerator. The denominator is 0.14. I simplify 0.32. Therefore, choice B is the correct one. In fact, this particular question takes longer to understand and implement. But that's the beauty of Bayes' theorem. Very, very interesting. It looks like a rocket science, but it's very simple. So choice B, 0.32. Let me now go to question 6. Market basket analysis. In a store, 40% of customers buy milk, 25% buy bread, and 15% buy both. What is the probability that a customer who buys milk also buys bread? Very simple problem. You should be able to do it in just 3 seconds, if not 2. Let me give the answer. The answer is choice B, 0.375. You are supposed to find out probability of bread given milk. That if you look at the wording, what is the probability that a customer who buys milk also buys bread? So probability of bread given milk is equal to probability of milk and bread divided by probability of milk using the conditional probability rule. It is probability of milk and bread divided by the denominator probability of milk, which is equal to 0.15, both buying, that is buying both, numerator, both milk and bread, probability is 0.15, numerator. Denominator, 40% of the customers buy milk, which is the denominator, 0.4. Dividing 0.15 by 0.4, we get 0.375. Hence, choice B is the correct one. With this, I have concluded MCQ part 2 of module 4. Thank you very much. We will see you soon in MCQ part 3. Thanks a lot.